Okay, this is an AQ application question. So the scenario is about electrical circuit. So you can read through the details yourself. So basically, there are a lot of variables, there are a lot of unknowns, and a lot of constants. So very important is there are a lot of quantities involved in this question. You need to identify which are the variables, which are the constants. Okay, so given in the question that R, C, L are constant, so take note of it. So let's write down the constants are R, C, L, right? And we also have other quantities. So the question says that the dE for the circuit is given as this. So this is the dE, all right, that shows the relationship for the various quantities, where I is equals to dq dt. So as we know, the independent variable here is time t. So part one, we need to show that under certain conditions, which should be stated. So take note that not only you have to show this, but you also have to state the conditions for V for which this holds. Okay, so you need to answer these two parts. So let's answer this part first. Let's show this first. So how do we show this from this dE? So let's write down the dE given. So let's take a look at which are the constants, which are the variables. So the constants are R, C, L. So these are the constants, okay? Then the rest are variables. So the variables are, of course, the independent variable, which is T. We have I is also a variable. Then we have Q, and of course we have V. So these are the variables, okay? Because it's not mentioned in the question that these are constants, so we'll take them as variables. So now our question is, how do we go from this dE to the dE that we are supposed to show? Okay, so the dE that we are supposed to show contains the second derivative, and the dE given contains up to the first derivative. So this gives an idea that perhaps we should differentiate. Okay, we should differentiate this dE. So we'll start with that. So we will let us call this equation 1. So we differentiate equation 1 with respect to the variable t in the hope to get d2i dt2. Okay, so how do we do that? Now when you're differentiating, do be careful. Take note of which are the variables that are constant. So in this case, L is a constant, all right? So therefore when we differentiate this expression, L is a multiple, it's a constant multiple, so we can just copy down L and then just differentiate the I dt, which gives us the second derivative. And then R is also a constant. So again, it's a constant multiple. So we just need to differentiate I, which is a variable with respect to t. And the third term here, Q is the variable. C is a constant also. So you can see it as like 1 over C times Q. So to differentiate 1 over C times Q is just 1 over C differentiate Q, because Q is a constant. So it's dQ dt. And V is a variable, so we differentiate, becomes dV dt. All right. So let's take a look at whether we're on the right track. So it seems that we've gotten some terms over here. So we are also given a question that I is dq dt. So let's replace that with I. Okay, we're almost there. So we have this term. We have the first term, we have this term, and we have this term. All right. So in order for us to show this, dv dt has to be 0. So we see that when dv dt is 0 for all values of t, we will get this dE, which is what we are required to show. Right? So we need to state the condition where dv dt is 0 for all t. So when is dv dt 0 for all t? So since we let dv dt 0 for all t, this happens where v is a constant. So this is actually the condition that we need to state about v. So under this condition, we have this dE that holds. Okay, so we have shown that the dE equation holds when v is a constant. Okay, let's try to further understand. Some of y'all may have other answers like, can you say when v is maximum or minimum or even 0? How about these answers? Are these correct? Now, take note that dv dt is 0 for all t. So the implication means that if you think of it graphically, right, at all values of t, dv dt is 0. So which means that we would expect the graph to be a horizontal line, right? So for horizontal line, at all points, at all values of t, dv dt is 0. So therefore, t is supposed to be a constant. So it is incorrect to say v is maximum or v is minimum. V is only maximum and minimum at a certain value of t, but in this case, we are letting dv dt to be 0 for all values of t. So therefore, we conclude that v should be a constant. So this is the condition for v. V is a constant. Therefore, dv dt is 0 for all t. And when that happens, this relationship holds. That's how we show it. Okay.